All right, so now that we've looked at what it means to have constant motion in terms of how that object is moving, what we want to do is we want to define this in a little bit more precise way. So today we're going to talk about a couple things when we talk about displacement and total distance and the difference between those two things. So at the end of this lesson, you should be able to define an object's reference point and determine an object's displacement and also the total distance that it travels. So we really want to look at the difference between the total distance that it travels and its displacement. So in your notes, make sure you've answered the questions. What is a reference point? What is the difference between the distance an object travels and its displacement? And what do we mean when we say an object has a positive displacement or a negative displacement? Let's look at distance first. Distance is abbreviated with the symbol d, and it is how far an object travels. Distance is a scalar quantity. Remember, that means it does not require a direction to describe it. So when we say we traveled 37 miles to Manhattan, we don't have to worry about which direction we traveled in. So if we have our ant that's standing there on the 0 centimeter mark, and it moves over to the 3 centimeter mark, what is the distance that he travels? Seems pretty straightforward, and he travels 3 centimeters. So now imagine that the ant starts on the 3 centimeter mark and moves back towards the 0 centimeter mark. He still covers a distance of 3 centimeters. Does his direction change the answer? It doesn't. In both cases, the ant moved 3 centimeters. That is what we mean when we say distance traveled is a scalar quantity. It doesn't matter what direction, we only care about the magnitude. When we talk about displacement, we're talking about an object's change in position relative to some reference point. The reference point is one of those things that a lot of times we imply, but we don't specifically state it. It is the point from which you take your measurements, and that is up to you. You can define your reference point however you want. For example, say you were talking about going to Manhattan. If you are in Council Grove, you'd probably say that your reference point is Council Grove, and that you would need to travel about 35 miles to get to Manhattan. However, if you're in Alta Vista, you probably would define your reference point as Alta Vista and say you only need to travel about 20 miles. Position is also one of those things that you have in your head but have never really defined. An object's position is simply its place in space as it relates to the reference point. Now, there's actually quite a bit to unpack here, so let's start with position. An object's position is its place in space. So take our ant. He is sitting at the 0 centimeter mark, and this means that he is on our reference point. So we can say that his position is 0 centimeters. We are going to symbolize this with an X that has a subscript I. The X is the symbol for the ant's position. The I subscript means that this position is where the ant starts, or its initial position. Now say our ant moves to the 3 centimeter mark. What is his new position? Well, now he's at the 3 centimeter mark. We are going to symbolize this last position with an X that has a subscript F. The X still stands for the ant's position, but the F means that it's in the ant's final position. So XI is where he starts. XF is where he ends. So what is the ant's change in position? In science, we use the Greek letter delta to represent a change in something, and it has a very specific meaning. Delta X, or change in position, is found by taking the final position minus the initial position. So we will take the final position of 3 centimeters minus the initial position of 0 centimeters, and we get a displacement of 3 centimeters. Displacement is a vector quantity. That means that we need to include the direction of the displacement. And there are several ways to do this. We could say that the ant has moved 3 centimeters to the right. We could also use the cardinal directions of north, south, east, and west and say the ant moved 3 centimeters to the east. Another common designation is to say that the ant has moved a positive direction. So a positive direction just means that it's moving in the direction we define. So in this case, we have said the ant going to the right is in the positive direction. Since we defined our first ant, so our first ant over here at this 3 centimeters, we defined as positive. We can also think of the direction as a number line. To the left of the reference point, positions of the object are recorded as negative positions. On the right side of the reference point, the positions are described as positive positions. So our first ant, we said moved to the right, and we called that a positive direction. So since our second ant moved to the left, we would say that it is a change in position in negative 3 centimeters. So notice that saying positive and negative when describing an object's position is not the same as positives and negatives in math. In science, positives and negatives indicate direction. So what about this guy? How would you describe this displacement? The ant still moves 3 centimeters, but he is moving up from the reference point. So we could just say 3 centimeters up. If we wanted to use the cardinal directions, north is typically written at the top of the page, so we could say 3 centimeters north. We can also define a positive and negative direction for the vertical as well. Usually we define up as the positive vertical direction and down as the negative vertical direction. So we would say that the ant moved 3 centimeters up. Now, one thing I want to point out here, position defines an object's place in space. When the ant was moving left and right, we indicated that with a delta x. X indicates that the ant is moving in the horizontal direction. Just like on a graph where the horizontal axis is the x-axis, we say we are moving in the horizontal direction, and we call that the x direction. When we say the ant is moving in an up and down direction, just like on a graph, we indicated that as a change in y. So our ant can move left to right, or in the x direction. It can also move up and down in the y direction. Now think about reality. We often move in 3 dimensions. What is the third? The ant could be moving in a direction that would, from this perspective, be moving into or out of our computer screen. So we would say that he is moving in the z direction. So just keep in mind that the symbol that we use for displacement will depend on which direction that the object is moving. So if he's moving left to right, we call it a delta x. If he's moving up and down, we call it a delta y. If he moves away or towards, we call it delta z. Now let's look at this one. Say the ant starts at the reference point and walks to the 5 centimeter mark. He turns around and he walks back to the 3 centimeter mark. How far did the ant travel in total? Well, he went 5 centimeters to the right, and then he turned around and traveled another 2 centimeters to the left. So the total distance that he traveled was 7 centimeters. What would be his displacement? Remember, the displacement is the overall change in position, and we can find it by taking the final position minus the initial position. The ant started at 0, and he traveled quite a bit from there before he finally ended up at the 3 centimeter mark. So his final position would be a positive 3 centimeters, and his initial position would be 0 centimeters. Taking the final position minus the initial position, and we would have a positive 3 centimeters minus 0 centimeters, or positive 3 centimeters as our displacement. So our displacement is 3 centimeters to the right. So here's another one. He starts at the negative 6 centimeter mark, wanders over to the 8 centimeter mark before turning around and finishing at the positive 4 centimeter mark. What is the total distance that he traveled? Well, going from a negative 6 to 0 is 6 centimeters. From 0 to 8 would be 14 centimeters. And then from 8 to 4 would be a total of 18 centimeters. So the total distance that he travels is 18 centimeters. What about his displacement? Remember, we take the final minus the initial position. The ant ended at the +4 mark, where he started at the -6 mark. So +4 minus a -6 will give us a displacement of a +10 centimeters. So even though he traveled a total distance of 18 centimeters, he only ended up 10 centimeters away from where he started. And since he ended up to the right, we say his displacement is positive. So you try one. Pause the video and determine the distance traveled and the displacement of a girl who walks 5 meters to the east and then 3 meters to the west. So how far does she travel in total? She goes 5 meters to the east and then another 3 meters when she turns around and comes back to the west. So her total distance that she travels is 8 meters. So what about her displacement? So she started at the 4-meter mark. If it helps, you can write down a ruler. It doesn't really even matter, but it kind of helps sometimes to see those numbers. And you can start it anywhere. It doesn't even have to be at 0. So we're going to start her at the 4. And she's going to move 5 meters to the east in the positive direction. And then she's going to come back in the negative direction or to the west for 3 meters. So where did you start her? She started at 4 meters, if you can remember that. So our initial position would be 4 meters. Our final position is 6 meters. And so we're going to take our final minus initial, 6 minus 4, and she has a displacement of a +2 meters. So she ended up 2 meters to the right of where she started. Okay, one more. What is the distance and displacement of an athlete running around a 400-meter track 3 times? Pause your video and see what you come up with. So the distance that he travels is 1,200 meters. It's a 400-meter track, and he travels around it 3 times. So the total distance traveled is 1,200 meters. But where did he end up compared to where he started? He ended up in the same place. So if you end up in the same place that you start, no matter how much distance you cover in between, your displacement's going to be 0 because your final position is the same as your initial position. All right. So do you know what a reference point is? Can you determine an object's displacement? And can you determine the total distance that an object travels?